So in this video, I wanted to take some time to do a few more examples with the power rule, because sometimes they can be a little bit tricky, and even though we're applying the same basic rule every time, sometimes we need to use a bit of simplification to make things a little bit easier to then apply the power rule. So the first example I want to start with is if we have y equals 6x cubed. And so if you remember from the last video, if we want to find the derivative of this y prime, what we do is we take whatever exponent was up here and we put it out front. And now you might be wondering, well, what happens when there's already a number out front? And so when I say put it out front, I mean it gets moved out front and it's multiplied by whatever is already here. So we take the 3, we put that out front, and that gets multiplied by any constant, any number that was already there. And then again, we subtract 1 from the exponent. So 3 minus 1 is going to be 2. And then we can simplify this a little bit because we know that 3 times 6 is 18. So we can say that y prime is 18x squared. So if there's already some number, some constant out front, then when you bring down the exponent gets multiplied by whatever number was already out front. So a similar thing, if we have y equals 3/4 x squared, and we want to use power rule to take the derivative of this. We take the 2 and we multiply it by whatever is out front. So we're going to have 2 times 3/4, and then we're going to subtract 1 from our exponent. So that's going to end up 2 minus 1 is going to be 1. And again, we can simplify this here. 2 times 3/4 is going to be 6/4, and 6/4 is the same thing as 3/2. So we can say that y prime is equal to 3/2 x. So again, if there was already a number out front, I just took the exponent and multiplied it by whatever number was already out front. So where things might get a little bit trickier is if I have the function y equals 5/x. And this is a situation where a lot of students will not be sure what to do. And so before I do anything, because a lot of students will look at this and go, well, power rule, like where's the power? I don't see, this isn't in the usual format that all the other questions have been in. So before we even try to take the derivative of this, before we try to use power rule, what I'm going to do is I'm going to rewrite this just using an algebraic rule. So I'm going to just rewrite this. I'm not taking the derivative yet. I'm just rewriting this, and I'm going to rewrite it as 5 times x to the negative first. So what I just used here was an exponent rule. If we have something in the denominator, we can bring it to the numerator by giving it a negative exponent. So if you are confused by that step that just happened, go review your exponent rules because that is what I used here. So again, I did no calculus so far. I did not take the derivative. All I did was rewrite this in a different form first, because now power rule looks a little more straightforward. It looks a little more obvious what we should do. So now that I have y written in this new form, I'm going to find its derivative. So using power rule, I'm going to take whatever my exponent was and multiply it by whatever number's already out front. So -1 times 5 is going to be -5. And then I'm going to subtract 1 from my exponent. So -1 minus 1 is going to be -2. And so this is my y prime, -5x to the -2. And so rewriting it before you use power rule is really, really helpful. So let's see another example where that is helpful. So if we have 1/x to the -2, hopefully you can see that we can use a similar exponent rule that I did in this question. So we can rewrite this. We can say y equals 1 times x to the 2. So again, I use my exponent rule that says if I have something in the denominator, I can bring it up to the numerator by making the exponent positive or changing the sign on the exponent. So now that I have it written in this easier form, now I can do power rule and actually find the derivative. So y prime, we're going to take the exponent and multiply it by whatever number is already out front. So 2 times 1 is going to be 2. And then we're going to subtract 1 from the exponent. So that's going to be 1. And x to the first power is just x, so you don't have to write that. So we can say y prime equals just 2x. So that is the derivative of this function, 1 over x to the negative 2 over here. So rewriting things using algebra first before you do any calculus can be really, really helpful. So where power rule gets a little bit trickier is if we have the function y equals 3 times the square root of x, and we want to find the derivative of this. So again, it's not all that obvious when you're first looking at it because you don't see a power, so you're not sure how power rule applies to this. So again, we're going to use an algebraic method to rewrite this function before we take the derivative of it, and that's going to be super, super helpful. So without taking the derivative, just by rewriting this function, I can turn this into y equals 3x to the 1/2. So what I did right there is I used an exponent rule to rewrite a square root as a power. So again, if that step confuses you, going from a square root to a 1/2 power, then review your exponent rules. So here we've just rewritten y into a form where now the power rule looks more straightforward. So if we want to find the derivative of this function, we want to find y prime, then again we're going to take the exponent up here and multiply it by whatever number's out front. So 3 times 1/2 is going to be 3/2. And then we're going to subtract 1 from the exponent. So that's going to become negative 1/2. And that's going to be your derivative. Y prime equals 3/2 x to the negative 1/2. So I'm just going to say now, whenever you see a square root in calculus, almost always it is an awesome idea to rewrite it as a 1/2 power every single time, because it is going to be super helpful when you take the derivative. So I would recommend that you just get into the habit. As soon as you see a square root, you rewrite it as a 1/2 power. So another example that we can look at is if we have a function y equals 4 divided by the cube root of x. And we want to find the derivative of this. So again, we're going to want to use some algebraic tools first to rewrite this into an easier form. So the first thing that I see right here is that we have a cube root. And I know I can rewrite cube roots by taking whatever the base is and raising it to the 1/3 power instead. So I'm going to turn this into y equals 4 over x raised to the 1/3. So what I did is I rewrote that cube root as a fraction. And now I realize that I can also rewrite this by taking whatever's in the denominator and moving it up into the numerator by giving its exponent the opposite sign. So I can say y equals 4x to the negative 1/3. And so now I have a situation again where power rule looks more obvious. So if we want to take the derivative of this, 4x to the negative 1/3, we can say y prime is going to equal negative 1/3 times 4, which is going to be negative 4/3. And then we're going to subtract 1 from the exponent. So negative 1/3 minus 1 is going to be negative 4/3. And that is going to be the derivative. This y prime right here, negative 4/3 x to the negative 4/3, is the derivative of this function that we started with over here. But you can see by first rewriting that cube root and then taking that what was in the bottom and moving it to the top made it a lot more easy to deal with this and to take the derivative. So really, really try to get in the habit of doing both of these things. Rewriting whenever we have a root, and then whenever something's in the denominator, moving it to the numerator. That'll make using the power rule way simpler. The last thing I wanted to briefly go over is finding the first and second derivatives. So we talked a little bit about what the notation for finding a second derivative is, but I wanted to do an example. So if we have y equals x to the 6, we know that if we want to find the derivative of this looks like it's just going to be power rule. So y prime should be 6x to the 5th. So we move that 6 out front, and then we subtracted 1 from the exponent. But now, what if I wanted to find y double prime, or the second derivative of y? And so that process is the exact same. If you want to find the second derivative of some function, you just take the derivative twice. Or you find the first derivative, and then you take the derivative of that, and that will give you the second derivative. So if we want the second derivative, we're going to take the derivative of the first derivative. So the first derivative is 6x to the 5th. And we want to take the derivative of this. So we're going to multiply that 5 by whatever's out front. So 5 times 6 is going to be 30. And then we're going to subtract 1 from our exponent. So 5 minus 1 is going to be 4. And so this right here, 30x to the fourth, is our second derivative of y. So it's just the same process if you want to find second derivatives. You just take the first derivative and then take the derivative again. And so similar thing, if we have y equals 8 times the square root of x, and we want to find the first and second derivative, well, first we have to start with the first derivative. And again, immediately we have a square root here. And always, 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 when you see a square root, rewrite it as 1/2 power before you start doing any derivatives. So I'm going to rewrite this as y equals 8x to the 1/2. And so now I'm going to use power rule on this to find the first derivative. So if we do that, y prime is going to be take the exponent, multiply it by whatever is out front, so 1/2 times 8 should be 4, and then we're going to subtract 1 from the exponent. So 1/2 minus 1 is going to be negative 1/2. So 4x to the negative 1/2 is the first derivative of y. And if we want to find the second derivative, we're just going to take the derivative again of the first derivative. So looking at y prime here, if we want to take the derivative of that, negative 1/2 times 4 is going to be negative 2. And then we're going to subtract 1 from the exponent. So negative 1/2 minus 1 is going to be negative 3/2. And so that right there is your second derivative of y. And we found that just by taking the first derivative and then taking the derivative again. So hopefully this video was helpful to give you some kind of unique examples of power rule. If you run into any other problems or kinds of problems that you would like to see done, then make sure you leave that in the comments, and don't forget to subscribe.